Okay, in this example, we have a similar problem as the last one, except this time we're told the mass because we put our vessel on a scale and we're able to weigh the ammonia. That's what I'm kind of depicting here. And we know we have 100 pounds of ammonia, okay? And it's a liquid, saturated liquid ammonia that's 35 degrees Fahrenheit. And we need to figure out what volume container do we need to have to hold that liquid ammonia that's saturated at 35 degrees Fahrenheit. Okay, so it's kind of last time we were given a volume, needed the mass, we're doing the reverse of that. So let's use our saturation table, okay? Have it with me. I'm gonna turn to the ammonia table. That's important to go to the right table and go to 35 degrees Fahrenheit on the far left column. And because we're dealing with a liquid, I'm gonna use the common convention, which would be to work in units of density. So I'm gonna find the liquid density by going to the 6th column, measured from the left, or reading from the left, and find that the liquid density is 39.76 at these conditions. And that would be pounds per cubic foot. Okay? So believe it or not, we now have everything we need to solve this problem with simple math. Let's figure out what our volume is. So volume is going to equal our mass divided by our density. Okay? Let's plug in our numbers. Our mass is 100 pounds, and our density is 39.76 pounds per cubic foot. Okay, the pounds will cancel because the units of cubic feet are a denominator of a denominator. It'll actually move back to the top, and we learn by using our calculator that the answer is 0.76. is 2.52 cubic feet. So we need a container with a volume of 2.52 cubic feet to hold 100 pounds of saturated liquid ammonia at 35 degrees Fahrenheit. Just like the other problems, we could have also solved this using specific volume, because volume equals, or big V, equals mass times little v specific volume. Our mass is 100 pounds. Let's look at what the specific volume is at 35 degrees Fahrenheit. Okay, so now I'm going to go to the 4th column, and I find that the specific volume of liquid, 35 degrees, is 0.0252. That's cubic feet per pound. And we probably don't even need to use a calculator because 100 times something, we're just gonna move the decimal 2 spots. We figure out the answer is what we already know it to be, which is 2.52 cubic feet. That is the volume needed to hold that liquid ammonia. A common pitfalls that I see people run into with the saturation tables, first is selecting the wrong table. So if the question is to solve some problem related to ammonia and you use the R22 table, you're for sure going to get the wrong answer. So step 1 is to use the right table. Second, I notice occasionally people will look up a gauge pressure value but use the absolute pressure column. So that's another important thing to be careful of. An easy mistake you can make that will land you at the wrong answer. And then third, is people just being intimidated by the units and guessing which column they should select a value from, maybe mixing up specific volume and density because the units aren't clear to them.